We've been talking about probabilities and normal distributions. In this video, I'm going to show you how to find those probabilities using Desmos. Here's the example we have been working with. We want to find the weight of a shovel full of dirt. We find an average weight of 15 pounds with a standard deviation of 2.4 pounds. We want to know what the probability is that a single load of dirt is under 13 pounds and the probability that a single load of dirt is over 13 pounds. So the first question, we want to see what the probability is of a single load of dirt under 13 pounds. We found the z-score to be negative 0.8333. And so probability of a load being under 13 pounds, that's the same thing as saying probability of a z-score less than negative 0.8333. What does that look like in a graph? Well, you have your normal distribution with a z-score of negative 0.8333 right about here. And then under that z-score means everything to the left. So you start here at a value of negative 0.8333, and you go out into the left tail. How far? Well, you go till the tail ends, which is negative infinity. It's going to go all the way as far as you can imagine to the left. Okay, so how are we going to find this area using Desmos? Let's pull up Desmos and show you. So to create a normal distribution, we just type in normal dist, meaning normal distribution, and then you need a set of parentheses. The parentheses will come into play later. Then, did you see there was a magnifying glass right here? I could just click on the magnifying glass and it will zoom in to my normal distribution. Okay, again, this curve is the density function, but that's not going to help me by itself. What I need is to find a certain value, negative 0.8333, right around here, and then find the area to the left of that. We're going to do that with this cumulative probability. So I just click on that, and automatically it's going to shade a region. The default is to find the inner area between two values. I could switch to the outer area. That would be the area of the two tails, above one value and below another value. Or I could do a left tail or a right tail. We want to do under 13 pounds, so that is a left tail experiment. All right, and since we have a mean of 0 and a standard deviation of 1, you can see that right here. Oh, didn't mean to put that in, but that's all right. It does the same thing. Mean of 0, standard deviation of 1, that means we're dealing with a z-score. So I just put in the value of my z-score, negative 0.8333. And we get an area of 0.202. Click on the arrow. It will give you a more full probability, 0.2023. And as we have seen in the past, that is exactly the probability we need. Now, what's the probability that a single load of dirt is over 13 pounds? That would be the same as a z-score greater than negative 0.8333. Okay, there I can just switch and do a right tail from that same point, and it will automatically calculate the probability for me, 0.7977 if we round. And sure enough, that is the exact probability we need. All right, now in Desmos, it's great to put in z-scores, but Desmos has it built in where you don't actually need the z-score. You can use the data itself. So I'm going to create another normal distribution, but this time, instead of a mean of 0 and a standard deviation of 1, I'm going to put in the data for my problem. And see, we had an average of 15 pounds and a standard deviation of 2.4. So I'm going to put in a mean of 15 and a standard deviation of 2.4. I can't see it. It's off the scale now. So I can just hit the magnifying glass and it will take me to that normal distribution. This looks like a different shape because, well, it is. This is our standard. The red one is our standardized normal distribution. The The blue is the regular normal distribution. All right, let's do the same thing as we did before. Cumulative probability. We want the area left of a value of, now we're not doing z-score, we're doing actual value, so I'm just going to put in 13. And then just so I can compare it, look, the probabilities are exactly the same. 0.202337. This looks like it's a little bit off. That's probably because this z-score was rounded. If I put in less rounding, 0.20232838, 0.20232838. Yes, it becomes the same. Okay, so it was just a rounding issue when I put in my z-score up here. All right, so point being, I can put in the mean and standard deviation into my normal distribution. And then under cumulative probability, I can do a left tail, looking at any actual value less than or equal to 13. And if I switch that to right, then you can see the probabilities turn out to be the same here as well.